Okay, I'm a little late to the party on this one, but this is going to be a solve of the final Road to Las Vegas round, Kiwi Holiday. Basically, we have a bunch of families that have preferences on certain attributes for a holiday, and then we have those holiday destinations and their attribute ratings, and we're trying to find the best holiday for each family. There's also an element of how far it is. There's a distance table here between locations. So as we go through the case, we'll be able to get kind of a score for each destination for the families and then adjust that based on how far it is away, because nobody wants to travel really far. Anyway, let's get into it. I actually have OA Robot now, so I can import my lambdas with a command. So I'll use a couple of other things I've built in it, but I haven't learned too much about it yet. Setup wise, let's call this distance. Dist will do. Family data, let's just call that attribute, so ATT will do. So first off, we want the most common attribute number, so that's going to be at most of attributes. Then we want to know how long it takes to go from these locations via Nelson, so let's just spill that out here. So we want to go via Nelson, so Nelson has to be in the middle, and we're going to Gisborne, I don't know how you say that, but there we go. So we basically want to get the distances, so we can say TLOOKUP distance table, and it's from here to here. We also need to know if this is in the north or south of the island, because that adds some distance. So these are like the North Island places, these are the south. So I'm just going to do a bit of a cheat here. I'm going to put an N there, and then I'm just going to say XLOOKUP these in here and give me here. And if it's not there, give me an S, because if it's not the North Island, it's the South Island. And let's copy those as values. So now I have a lookup for that. So let's do XLOOKUP these in our distances and give us whether it's north or south. So we're only going to cross north and south once. So then let's do, well, same as this again, just to get the distances. And then the time is going to be that over 80, because we travel at 80 kilometers per hour, over 80. And we need to add 3.5 for the ferry crossing. Do we need to add customs? Don't know, but it looks like 22 is the answer. Okay, this without customs, 22. This relies on level 3, so we'll wait for level 3 and let's get to it. So firstly, we just want the attribute number for the family and destination. So that's a TLOOKUP on the attributes with from family destination. And that TLOOKUP is literally just a two-way kind of index match on this table. Is that one done? Then we want to find which family has this as a first attribute and this as a second. So we are just filtering this for where the first one is what it says and the second one is what it says. So we can just use the filter formula there. Filter the families, and we need to remember to lock it, where this equals first destination times this equals the second attribute. I think I said destination before, but I meant attribute. And we need to wrap those in brackets if we're doing a two-way one. There's also a kind of tricky bit in this question that says that if it's no particular favourite, put no family. So let's use the if empty argument and put no family, and that should give us all the answers for that one. Okay, level 3, this is where it gets a little bit more tricky. We're trying to find the score for each family. So let's set up a data table. I have a robot command for that now. Example 3, and I want to type this as a hard-coded value. The way I've done the macro kind of doesn't work with the data table unless I hard-code the first value, but whatever, I'm not that bothered about it. So I want to basically XLOOKUP the family. So this is the Baton family in here, and return what their most important attributes are. And the way the scoring works, basically the first attribute list is worth 1, and then everything else is worth 0.1 less. So this is the worth of the attributes. And then let's just pull out all of the attribute names over here, and the scores for the destination. So we can say XLOOKUP the destination in here, give me the scores. And we basically want to apply this modifier to all of these scores. So to do that, we can just do another XLOOKUP all of these in here and give me that. And if it's not there, give me 0.4. The instructions tell us it's 0.4 if nothing's there. So the score is then going to be the sum product of this and this. That's our score, and we just need to round it. So let's say round this. And let's create a data table. There we go, that's question 3. And I think we can also do a bonus now. So bonus 3 says, under these rules, which family would enjoy traveling to Auckland most? So that's already there. So let's just hard code that as a value for a second. And what do we want to do? This is going to be dependent on this. And then this is going to be dependent on the family. So let's put the family out here as well as a static value. And then we can just do a data table on all the families. So let's do that. Okay, so let's run our data table again here, but this time we're changing the family instead. And apparently I can't do that, so let's try again. It depends on the family. There we go. So we want the maximum one here. So I can see it's 31, so if we look for a 31, it's this key family. That was actually a bit risky because I probably should have taken the rounding off of that, because 2 could have had the same score. Anyway, doesn't matter. Okay, now let's finish all the rest of the questions and we'll go back to bonus 4 and 5. So this one is just asking, they can visit multiple destinations. How long does it take to travel from one destination to another? So this is just traveling now. So let's just set up my data table again, and this is question 4 at this point. So we are going to do the score off of this family. Don't need this here anymore. Maybe not. These are destinations, not families, so the family is not actually there yet. Now we want a distance. So for distances, we basically have time to destination. So let's actually call it driving time. Driving time is going to be a T lookup of in the distance table, and we're going between these 2 locations. So that's going to give us how many kilometers it is, and the driving speed is 80, which is in the instruction, so it's that many hours. We also need to know if these are North or South Islands. So I'm going to say X lookup this in here, and give me this. Because if we travel between North and South, we need to add on 3.5 hours from a ferry trip. So let's say ferry. So that's if this equals this, then 3.5, otherwise 0. Sorry, if it's the other way around, so 0, otherwise 3.5. And then our total is going to be 14, so we can just say equals this. I have a robot command that also wraps like things in a round 0, so I've got Control-Shift-Z for that. That's what I just did there, so that's a big time save. And question 4, we now need to redo our data table, but from here. And we can't do it until we delete our old data table out, because that's running off of something else right now. There we go, and that should work. We get an error. Why? It's because this is the whole thing I said about earlier where my lambda is not set up properly. I need to manually hard code this to let the data table work. It's annoying that data tables don't work very well when there's formulas in there. Anyway, that one's done. Question 5, now the attribute scores affected how long it takes to get to the destination. So this is example 5, this will be 81. And now we have the McCaw family, and they're going from, what's the question? They're always going from Wellington. So all families go from Wellington and must go through customs first. So now we have a customs here. Customs is going to be 2 hours always. So the actual full distance is going to be this. Our destination is going to be to Wellington, so let's just put Wellington here. And we want to go from Christchurch to Wellington. The ferry is going to be between Christchurch and Wellington. So, and what are we asking for? Are we asking for the score? Yes, so the score is going to be this. So we want to do equals this, and we're going to do our rounding. And now we need to apply our modifier for the time. So it's going to be that times 0.02. And then this score is going to be that times 1 minus our modifier percentage. So this is our new score. Our destination is Christchurch. I think that's it. Let's see. Yes, it is. Okay, question 6 is the same thing, but we want to go to all locations and see which one is best. So let's do example 6 here, and this is going to be 101. So the family position has changed there, and the destination is, that's the port of entry. So we want to flex the destination in a data table. So I've put all destinations across here. Let's just pretend the destination is Wellington for now. So driving is going to be between port of entry and that, and then the ferry is going to be determined on them. So this should be our new score, but we want to check the score for every destination. So we'll just do a quick 2D data table. Let's delete that out. This is our score. We don't want to round that either. We'll only round at the very end. And then our possible destinations are these places. So then we just do a 2D data table between question number and the destination we're going to go to, and then we get all the distances for destinations, and we want to say xlookup max of this in here and return the destination. Let's just put some brackets in. So that's what we want to return, and a dash and the round of the max of this, comma 0. And then we should have the destination with the highest score. I didn't lock my headers here, so let's just do that. So yeah, this is the highest score and the destination written in the format that the question would like. Now finally, question 7 before the bonuses. Now we have the same thing, but we have the option to fly to any port of entry before we make the drive. So it's this, but with 3 more options overlaid, basically. So let's add those 3 options in. So let's quickly grab all my ports of entry. So I'm going to filter the ports of entry where the ports of entry is not the one listed in the question. Here we go. And our family now is the Shepherd family, and our destination can be Wellington. That's fine, because I'm going to check all destinations anyway. Then to drive, the first option is going to be to drive from there to there. And let's do 3 options, options 1, 2, and 3. The next option is going to be to drive between this port and Wellington. And the next option is going to be to drive between this port and Wellington. But we also need to add a flight distance. So let's add the flight distance. So in the first option, we're going to have to TLOOKUP the distance again. So let's actually just drag this up, and we want to TLOOKUP distance between. So this is flying. So we're always gonna fly from the question place to here in this first option, and it's going to be over 800. We're told in the instructions that 800 is the speed for flying, and then we can do the same thing to find how long it takes to fly from Christchurch to the other port of entry, which happens to be Wellington. Doesn't matter that this is Wellington. I could have put that as anything. Let's put Nelson to not get confused between ports and destinations. And I also need to do this xlookup to find the north-south, because our ferry distance for the first option is going to be from Christchurch to our destination, but then it's going to be from Auckland to our destination, then it's going to be from Wellington to our destination. Customs is always going to be 2 hours in all cases, and then we basically want to grab our distances, or times should I say. So this is the time under options 1, 2, and 3, and the score is basically going to be the minimum of these 3, because we want to get the maximum score. So because this is descaling like our score, we want to take the smallest impact. So I think that's correct if I change my question numbers. Hopefully I haven't missed anything there. Soon find out. There we go, question 7 done. So bonus 4, we start in Whangarei and continuously drive to the nearest destination what distance will you cover by the time you land in Queenstown, but you can only go to each place once. So I can just use this table to do that. So I start in the first place, so let's just say equals that, that's my first place, and I want to basically spit out where we're going to go next. So I can say xlookup this in here and return the distances. So that will give me all the distances there. And then I want to say sort by these, and I'll lock it where that, and I want smallest to largest. So I want ascending distance. That's going to give me all the shortest places. Obviously it's quickest to go to where I already am, that's 0 miles. And then the next closest is Auckland here. So I want to actually filter this out. Filter this, let's put let A be that. And I want to filter A where is error, X match A in here. And I will make that come down with us as we go. I only want to lock this one. Okay. And what's that's going to do is if I've been there before, it will eliminate it. So the next place is now just going to be the first one there. Let's just actually take only the first one because that's all I need. And if I've done this right, then I need to lock some stuff. Let's lock that. I think that's right. Then if I drag these two down, that should just give me all the places. Let's just check what's going on here. Still not locked. There we go. So this is kind of the route I take in theory. So where do I get to Queenstown? That's here. So I just need to go tlookup. It's going to be the distance table. So distance, and the first entry is this, and the second entry is this. That's going to tell us how many kilometers we go to get to Queenstown, and the sum is 2384. So 2384. Yeah, when I did this for real, I actually just manually went, okay, this is the closest, and I sort of highlighted like this, and then went, okay, Auckland, and then I scanned across here, looked for the minimum, which is 125, and then went, okay, there, and just filled it in like that. It was pretty quick, but a formula way is a bit cleaner, I think. Anyway, final bonus, consider all possible destinations for all families from all ports of entry. What family can achieve the highest total attribute score? So I've already got this set up, so it's just this again. So all I need to do is fix these as static values, and then I need to do a data table for all locations and all families. So let's just check everything's going off the right place. That's going off there. All locations, we could just set Christchurch as our... could we set Nelson? Yeah, Nelson will be fine. That's fine. Christchurch is going to be static, so we're going to get the all ports, I think, and all destinations. Yeah, okay, so that should be fine. Yeah, all right, let's grab all... well, we've got all destinations, so we just need to grab all families. So let's just delete our data table out like that. And let's grab all of our families. So we can put the families down here, and then we can data table like this. And we want to change the family, and the row input cell is going to be the destinations. This should give us all of the possible scores. So we basically want the maximum one of those, which looks to be 32, and find which family it is. So let's say max of these. 31.3, 31.4, 31.7, it looks like this one. Umaga family. Okay, there we go. That is the final Road to Las Vegas battle done. Just as an outro, it's probably worth sharing the videos I still need to upload on this channel because I'm getting into a backlog now. So we've got the first kind of stage of the World Championship today, like the proper World Championship, not the monthly Road to Las Vegas battles. So I've got that in 2 hours time. I'll solve that. I also want to finish uploading all the videos for my Excel course, and I want to do some more fun videos like what's my favourite cases of the year and a kind of a tier list of all the Road to Las Vegas cases. So hopefully I get some time to upload those. I've just been busy at work this week, hence this video being way too late, but there we go. Anyway, hope you enjoyed.